Plane geometry, section 1.8, measuring angles. We're going to start tying some of what we've known and talked about a little bit last section into what we're learning now. So we're going to start giving numbers to the different angles that we have. So measuring angles, when we measure any magnitude, the unit must be of the same kind as the quantity to be measured. So we know when we measure lines, the unit must be a unit of length. When we measure angles, the unit is one that corresponds to the angular measure. So we don't really measure angles in length. We're going to measure angles in degrees. So one of your keywords is degree. All right. Let's talk about the paragon. The paragon is the angle that goes at a full rotation. So we talked about if we have a point here, call it point O, and we measure the angle all the way back to that was a paragon. All right. And the way that we came up with the number of degrees, it's believed that it was the Babylonian astronomers and that they had figured there to be 360 days per year. And so they made it to where 360 degrees was a full rotation based off what they believed to be the number of days per year. Kind of a neat little history thing. So that made it to where a paragon, or one full rotation, was 360 degrees. So in Algebra 2, we talked about the unit circle. We learned a lot about it. 360 degrees is the going all the way around. But we can get a lot more detailed. Instead of breaking it up into 360 equal parts, written as degrees, so like 1 degree would be written as 1 degree, we can break that degree up. We're going to break that degree up into 60 equal parts. So we're going to call that a minute. All right, so 1 degree is equal to 60 minutes. That's the notation that we're going to use for it. So out of the 360 degrees, every single one of those degrees is broken into 60 minutes. And every one of those minutes is broken into, 1 minute is broken into 60 seconds. So you need to be familiar with degrees, you need to be familiar with minutes, and you need to be familiar with seconds. That just gets extremely detailed how far around. On something this small, you may not realize the need for minutes and seconds, because if you fit 360 equal units in this one little circle, that's going to be pretty detailed. But when you blow it up to the size of the globe, the size of Earth, and you start doing it in 360 equal parts, those get a lot bigger. So if you say something is located in between 4 degrees and 5 degrees, that may be a huge area that you have to explore. So you can break it up into 60 minutes and then into 60 seconds and get a lot more detail. We don't see the benefit of minutes and seconds so much on something the size that we would deal with on a piece of paper or on a dry erase board. But once we get out into the real world and you ask where would we ever use math, that's whenever we would need minutes and seconds. So we need to be able to convert from degrees and seconds to degrees only. So there's some examples. Example 1 wants us to express 35 degrees and 15 minutes in terms of degrees only. All right. So what we're going to do, the 35 degrees is fine. It's already in degrees. We just need to convert to the minutes. So we know that 15 minutes, it's going to be basically the equivalent to 15 over 60 because there's 60 minutes in a degree. So that's going to equal 1/4. So that would give us 1/4 is equal to 0.25. So the 15 minutes would become 35.25 degrees. All right, so that's equal to 35 degrees and 15 minutes. So when you're converting minutes to degrees, you're just gonna put 15 over 60. So how many degrees are there in a straight angle? I know we know the answer to that because we've already been in depth through quite a bit of trigonometry. We were in algebra 2, the unit circle, but what we learned earlier is that a straight angle is half of a paragon. Well, if a paragon is 360 degrees, if that's 360 degrees, a straight angle is half of a paragon. So a straight angle being half of 360 degrees would have to be 180 degrees. Therefore, a right angle, which is half of a straight angle, would be 90 degrees. All right, so that's kind of where those come from. We memorized them a long time ago. On number 3, it says to draw an acute angle, represent at its vertex the complement and the supplement of the angle. What is the difference between the complement and the supplement of the angle, and use an equation to solve it? So if I draw an acute angle, we'll start with a line, a straight angle there. I'm going to make an acute angle. Remember, an acute angle is between 0 degrees and 90 degrees. It's less than a right angle. So I've got an acute angle here. It wants me to find the difference between the complement and the supplement of that angle. So the complement of this angle, if I was to make another one here and call this a right angle, the complement of, I'm going to call this, we'll just call it angle A. The complement of angle A would be whatever is over here, it'd be B. The supplement of angle A would be whatever it took to get all the way over to 180 degrees. All right, so it wants me to find the difference between the complement and the supplement, and it wants me to do that using an equation. So we're going to say let A equal the acute angle. So the difference of 90 degrees minus A is going to be the complement. Right? The complement is the difference between A and the right angle. Then 180 degrees minus A is going to be the supplement. Okay, the difference between A and all the way over to a straight angle is the supplement. So we're going to let D equal the difference. And we're going to do it in degrees. All right, so the difference is going to be D. The difference is equal to 180 degrees minus A. Remember, I wanted us to find the difference between the complement and the supplement. This is the complement, this is the supplement. So to find the difference, I'm subtracting the complement from the supplement. So the supplement, 180 minus A, minus the complement is right there. Think back to algebra. You have these parentheses. 90 degrees minus A. So the difference is equal to the supplement minus the complement. So when I start cleaning this up algebraically, I'm going to get D equals 180 degrees minus A. I'm going to distribute that minus through, so I'm going to get minus 90 degrees minus a negative is going to be plus A. So now I've got my minus A and plus A cancel each other out. 180 minus 90, the difference
between the supplement and the complement is 90 degrees. All right, so the difference between the complement and the supplement, so it's gonna be a right angle, it's gonna be 90 degrees. So you have exercises 1.8 that you can work on for some extra practice. There's 11 questions there, it looks like. Then when we come back, we'll work on 1.9 using the protractor.